All right, so number one is a GCF. Anyone figure out what the GCF was? 3 and X. And then what's left over? 2x minus 9. Okay. Number two is difference of squares. Okay, 7x minus 11, 7x plus 11. And then there was a typo on number 3. So once we figured out it needed to be negative 48, then what did we do with it to factor? So multiply to negative 48, add to negative 2, you get negative 8 and 6, x minus 8, x plus 6, or you could switch them around and you're still correct. Okay. The next one we're going to need to be on Desmos to do, and we're also going to use Desmos today. So if you haven't gotten your Chromebook out yet, go ahead and grab it because you are going to need it. So we're typing in negative cube root. How do we type in a cube root? CBRT. Okay. X plus 2, and then we're going to make sure to get out of the cube root and then type the plus 8. Minus 8, sorry, minus 8. And it's down there. Okay. It says, what is the domain? How far to the left does the graph go? How far to the right does the graph go? Yeah, it goes forever to the left, forever to the right. So the graph kind of looked like this. Forever to the left, forever to the right. Okay. What is the range? How far down? How far up? Yeah, so it goes down forever and up forever, and we always write the down forever part first. So down forever and up forever. Okay. X-intercept is kind of tricky to find on this one because it goes up so slowly. So we have to find, we know that the x-intercept is going to be over here somewhere. It keeps getting closer to the x-axis, but it's really slowly. So I zoomed out on mine so I could find it faster. And then I knew it was over here, but I couldn't really tell where. So I just, I think I clicked over here. And then when I clicked over here, I wasn't on the right answer, but that little gray dot showed up and it showed me where the x-intercept was. So I could then go and click on it. Was everyone able to find the x-intercept okay? Yeah. Negative 514. Yeah, so that was kind of a crazy x-intercept. Okay. And then we have our end behavior. So as we look at the left arrow of the graph, is that left arrow going up or down? Left arrow. It's going up. It's just going up very, very slowly. So is this a positive or a negative infinity? Positive. Left arrow is a positive infinity. Okay. And then the right arrow, does that go up or down? Goes down. So that's a negative infinity. Okay. Then over here, we got some stuff to plug in. So it says, take function g and plug in -7. So we're going to take out the x's and we're going to put -7s in there instead. So -7 goes in for x. And then since this is all numbers, we can plug that straight into a calculator. And if you plug that straight in exactly the way that it looks, what do you get? You get 84. Good. If you type it in exactly the way that it looks, you get 84. Okay. The next one tells us to take function k, which is over here, and take out the x and take 9m and put it in instead. We cannot use a calculator because it has a letter in it. So what are we supposed to do? Write it twice. The 9m is squared, so it says write it twice. The negative is not squared. Everyone see that? The negative is not squared. So we're going to have negative 9m is being squared, but the negative is not, and then plus 11. Okay, so we have the negative version of 9m times 9m. And what do you get if you have 9m times 9m? 81m squared, okay? And then the plus 11. And can the negative 81 and the 11 be added together? No, why not? Yeah, not like terms, m squared. This one doesn't have an m squared, so they're not the same. Okay. Next says take function h. H is 2x plus 7, so 2, we're going to plug something in for x, and then we got a plus 7. And the stuff that we're plugging in for x is k plus 2. And since there's a letter in here, we can't plug it in our calculator. What do we do with the 2 in the front? We distribute the 2 in the front. And so when we distribute 2k plus 4 plus 7, and are there any like terms we can combine? 4 and 7, what does that give us? 11, so 2k plus 11. Good, okay. And then over here, what does this notation mean? What are they telling us to do? They're telling us to multiply. They're saying take h of x and multiply by f of x. So h of x is 2x plus 7. F of x is x minus 4. And how do we multiply 2 sets of parentheses? You distribute, it starts with an F. We FOIL, yep. Okay, so we're going to do the first times the first. What do we get? 2x times x. 2x squared, okay. And then the O, we're going to do the outsides. So this outside times this outside. 2x times negative 4. Negative 8x, okay. Then we're going to do the insides. So 7 and x are the insides. 7 times x is 7x, okay? And then we're going to do the last. The last term here times the last term there. So positive 7 times negative 4, negative 28, okay? And then we're going to put all of that together, and what does that give us? Okay. So when we combine these two terms in the middle, if we have negative 8 and positive 7, that gives us negative 1. All right, make sure your name is on your warm-up and get your warm-up turned in. You're going to get participation credit for the warm-up today. So go ahead and get the warm-up turned in. You can turn that in. So we've already gone over how piecewise functions work. We're going to go over them again. And today we're going to use Desmos to graph the entire piecewise function. There's only going to be a very little bit that you have to do in your own brain. Okay. So what we were doing last week is we were graphing this entire piece of the graph, and then we would circle the number. And then we would say, okay, the arrow's going to the left, so I'm going to keep the left side of the graph. I'm going to erase the rest. Today, we're going to plug the whole thing into the piecewise function, so the piecewise, or into Desmos, so that Desmos can tell us, yeah, this is the only part you're going to keep. Don't even draw the rest of it, okay? So we're going to kind of shortcut the way that we were doing it last time. And then we're going to add one more piece to it. The piece to it that we're going to add is we're going to use Desmos to figure out what happens if you try to plug a number into the piecewise function. Okay, so the piecewise functions I've been giving you have only had 2 pieces, and so when we plug them into Desmos, we're going to plug them in as 2 pieces there as well. Desmos has a couple different ways you can plug in piecewise functions, and you can plug it in all at once, but I don't think that's very easy to do. So I'm going to have us plug it in using two different equations, because then we can see it as two different colors, and I think that's easier to graph. So go ahead on Desmos, and we're going to start typing number 1. So we're going to do 2 parentheses x minus 3 to the third minus 4. And then if we were doing this last week, we would have graphed it like this. And Christian, I need you to bring your headphones up here. They shouldn't be in at all. If we were doing this from last Friday, then we would be graphing this completely by using the points, and then we would figure out by hand how much we're keeping. But today we're going to let Desmos help us figure that out. So the way that we let Desmos do that is we want to get a squiggly bracket on the computer screen. And the way we do that is we hit Shift and we hit the keyboard button that's next to the letter P. So a squiggly bracket is right next to the letter P. You hit Shift and then the key right next to the letter P. Did everyone get that on their keyboard? Okay. And then inside that squiggly bracket, we're going to hit X. And then the less than sign is right next to the letter M on your keyboard. So Shift and then the button next to the letter M on your keyboard. And if you look on our paper, it says less than or equal to. And so if we want to do less than or equal to, we just have to hit the equal button, which is next to your backspace. So if you hit equal, it will slide an equal sign underneath your less than. Everyone got that? So now your Desmos should say X is less than or equal to. Everyone got that? All right. And then if you type -2, then you should be able to get your graph. And I'm going to get out of that. What did I type that was weird? Does everyone have a graph showing up, or is yours doing what mine did? Okay. Hang on 1 second. 2x minus 3 to the third minus 4.
Oh, wait. If you zoom out, it's right.
Yeah. Yeah, that's fine. Oh, you know what we need to do? Sorry, everybody, because we were just graphing for the warm-up. So if you have underneath this, if you have the little home button, go ahead and click that. It might have been because we were so zoomed in. Okay. Let me type mine in again, because I think that's why mine wasn't working. Goodness gracious. Right 3, down 4. No, it should be plus. Sorry, put a plus sign in there. That's a typo. Sorry. If you put a plus over here, I was like, I checked all these as I made this worksheet, but it would make sense if I had a mistake in there. Okay. If you fix this so there's a plus in here now, are you guys seeing it? That would be why. Yeah. 2x plus 3 cubed and then minus 4. Is yours working now? Okay, so when you type it, type 2 and then x plus 3 to the third and then minus 4. You should definitely see that, right? But do you have this? Okay. And then now put your squiggly bracket. The squiggly bracket is not a parentheses. And then the squiggly bracket, x less than equal to -2. And then it cuts off some of your graph. Will you let me see it? Oh, it's because you're still zooming. All right. So once you have it, go ahead and click the gear. and then click the table. And then here you're going to see it's undefined because the graph stops at this point right here. -2, -2, it stops. Because if we were to draw this, we would have drawn a circle around -2, and then the arrow points to the left, so we would have kept the left side. The right side we wouldn't have kept. So this part that says undefined, that's the right side that we would have erased if we had been drawing and erasing stuff. So I'm going to go up here after the -2 and press enter a bunch of times, and then I'm going to type in all the numbers that I'm actually keeping so that I can see some points that I can actually graph. Okay. And these are going to be hard for me to graph, but here -4, -3, -2 I can actually graph. So these 3 points right here are the ones I'm actually going to be able to graph. So -2, -2, I can graph. -3, -4, I can graph. -4, -6, I can graph. And then with this, the only part we have to be careful of is we have to make sure if the end point of our graph should be a dot that's filled in or a dot that's not filled in. That's the only part we're going to have to watch out for. Okay. And the end point that I'm talking about is this point right here. So the end point on the graph always was either filled in or not filled in whenever we drew these piecewise functions. So I'm going to show you what my paper looks like. So I'm going to be copying this to look exactly the way that Desmos looked. So Desmos looked a little bit like this, and then it looked a little bit like that, and then it kept going down. And then I'm going to draw an arrow over here to show that it keeps going down, and I'm going to have the graph stop. Because this piecewise function stopped suddenly. That's what happened when I put that squiggly bracket in. So if I go back up and take the squiggly bracket out, if I make it not a piecewise function, that's not a piecewise function, you can see it would be the whole graph. But when I make it a piecewise function, this is the part where I go back and I erase the part of the graph that I don't need. Does that make sense? Okay. So if I look at my paper, it says less than or equal to. And so that means that this point right here, should it be filled in or not filled in? Filled in. Okay, so I'm making sure that this right here is filled in. Okay, and then now I'm ready to go to the other point, x minus 3. I'm going to go ahead and type that into Desmos. So I'm going to type in x minus 3. Right now it's graphing the whole line because I haven't done the squiggly bracket part yet. And then the paper tells me to do x minus 3 if x is greater than -2. So now I'm going to type in the squiggly bracket and then do x is greater than 2. Sorry, x is greater than -2. And then it's going to cut off everything that I don't need. So x minus 3, squiggly bracket, x is greater than -2. Yeah. So it would depend on what size your screen is. So if I zoom out, then it looks a lot different. If I zoom in, what is what? Oh, you did +2 and I accidentally said +2 and then I changed it to -2. So here's me at +2, and if I stick a negative in front of it like the problem is supposed to be, I said +2 at first and then I realized it was -2. Yeah, that was my fault. Okay, so we're going to go back now and we're going to click on the gear and we're going to click on the table. And then you can see at -2, and you don't have to put more negative values in here, but if I did, you would see that those negative values are all undefined because that's the part of the graph that we would have erased. And then if we look at the other parts, those parts are defined. Those are actually points that we're going to draw. Now we do have to draw this point down here, -2 and -5. Do you guys see how that's a circle that's not filled in? So we're going to make sure we draw a circle that's not filled in right there. Does that make sense? That's the very end of the graph. So -2, -5, we're going to draw that. And then we're also going to draw these points. So -1, -4. Say it again. -1, -4, 0, -3, 1, -2, 2, -1. We're going to draw those. Oh, the rest of them are shaded in. Yeah, the rest of them are filled in. But -2, -5 was not filled in. And it won't even show up. It won't stay showed up for me. So -2, -5, I have to see that just by looking at my eyes. It won't tell me it's an actual point on the graph since it's not a filled in point. But I can see that's the point that would be there. And then since this is a straight line, I can kind of follow that pattern. But I'll show you guys what my graph looks like right now. So I have this point right here that is not filled in. And then I can see the pattern of the point. So I'm just going to kind of follow that pattern. And I know the left side is the side that got cut off. So now I'm just kind of drawing the right side. Wait for us to finish this one. Okay, so now here's the part where we just have to see what happens if I plug in the different numbers. So if you want to see what the output is with all those different input values, you just look at the two different tables that you have in Desmos. So one of the tables will have the answer, one of the tables will say undefined. They won't both have an answer. Okay, so if we look at Desmos, the first one says plug in -5. -5 here has an answer. It says -20. If I were to plug in -5 to this one, it would say undefined. So you don't ever have to wonder what the right answer is. One of them will have an answer. One of them will say undefined. Okay, so for number one, if you want to know what you get when you plug in -5, the answer is -20. If you want to know what you get when you plug in -3, what's the answer? -4. If you want to know what you get when you plug in -2, what's the answer? -2. Okay. If you want to know what you get when you plug in 0, can you use the first piece of the piecewise function? No, because it says undefined, right? So you got to go to the second one, and then what's the answer? When you plug in 0? What's the answer when you plug in 0? -3, right? Plug in 0, you get -3. What's the answer when you plug in 4? Okay, I got to make my table a little bit bigger. 2, 3, 4. When you plug in 4, you get 1. Okay, what about when you plug in 11? When you plug in 11, you get 8. Okay, now if I said, what about when you plug in 492? You don't have to go by ones in the table. You don't have to make the table bigger, like, okay, here's 11, 12, 13, 14, all the way up to 492. You can literally just type in 492 and get the answer. Okay, so any number you want me to plug into that table will give you the answer just by typing it in. Does that make sense? So once you've graphed it, you've done the hard part. Okay, let's go ahead and try the next one. So I'm going to delete these, everything that we typed. And Daniel, you can go ahead and go to the bathroom. Okay, so the next one says 2x plus 4. And then it says, but only if x is less than or equal to 0. So now I'm going to do squiggly bracket. X is less than or equal to 0. Okay. And then I want to get my table up so I can see the points. So there's my undefined point. So I might want some more negative values. So I've got like -6, -8, -5, -6, -4, -4, -3, -2, -2, 0, -1, 2, 0, 4. Is 0, 4 filled in or not filled in? Filled in, and you can tell because Desmos will show you. Either you'll click on it and the point shows up, or you'll click on it and the point will not be filled in and it will refuse to tell you what the y coordinate is. It'll tell you that it's undefined. Okay, so all these points are actually there. They're all filled in. And we know that we're going to draw these points. We're going to connect them with a straight line. We're going to show that the arrow is going to the left. So once you have graphed this part, then your paper should look like this. Everyone good so far? Okay. Now we're going to type the other part. So, negative x minus 1 to the third plus 2. Okay. And I don't want to keep the whole thing. I'm going to do squiggly bracket x greater than 0. Okay. And right there, I can see that that point right there, it's not telling me the y coordinate, so I'm going to have to use my eyes to figure out what the y coordinate is. Y coordinate looks like 3, but I'll be able to kind of look at the table. Maybe have that help me. So 0, 3 is where I'm going to draw my open circle. Okay. And then I'll do the other points too. So I'm going to go in here, click on the gear, get my table pulled up. Here's some more points. 1, 2, 2, 1, 3, -6. So we got that point that's not filled in. And then we got 1, 2, 2, 1, 3, -6. Those look like the easiest points to graph. So here's my graph. That's what I've got it looking like. And then if I want to see what these are going to equal, I'm just going to look at my two tables. So I'm going to plug in -20. So I can try plugging in -20 to this one. It says undefined. So what does that mean? If I plug in -20, it says undefined. What should I do? Say it again. -32. So I'm not going to look at this table. I'm going to look at the other table. -20. -36 is the answer. What do you get when you plug in -4? -4. We're looking at this one. Okay. What do you get if you plug in 0? 4. Okay. What do you get if you plug in 2? Yeah, you don't get undefined, right? We're going to have to switch to the other table. If you plug in 2, you get 1. If you plug in 7, you get Negative 2, 14. 15 is a little bit bigger than my table, so I'm just going to plug in 15 down here. Negative 2, 7, 42. Okay. All right, how do we feel? Can we use Desmos to plug these in? Okay, so I'm gonna let you guys do, there's 4 more problems to do. I'm gonna let you guys do those 4 problems. Plugging them in on Desmos and then figuring out what the points are. And then if you are missing the other assignments, you can go ahead and use this method to do them as well. That's totally fine. All right, go ahead and get started.